Objective 7 is an analysis objective, with the exception of a few problems at the end of the worksheet. The entire worksheet is all about analyzing a function or comparing two functions against each other. So in this first example, we only have one function, and that's the h of x function. It looks like it's an absolute value function going down, but we really aren't concerned about what the equation is right now. The first question, list all labeled points which are solutions to h of x equals 0. Well, the key word right there is solutions. Where is the answer to h of x equal to 0? So another way of writing that would be, where is y equal to 0 on the h of x function? Well, y is equal to 0 on the h of x function in these two places, at point W and at point X. Now the next question, list all the labeled points that are solutions to y equals h of x. Well, that's just simply asking for all the labeled points that are on the function. So it would be, if you want to just start here and go there, it would be y and W and V and X and Z. Now the next one, list all the labeled points that are solutions to x equals 0. So written like this, it would be on the h of x function, where is x equal to 0? Well, there's only one point where the x value equals 0, and that's right there, at point Z. And then if we had to label that as a point, well, think of the ordered pair. We really don't know what that number is, but we do know it has a name, and that's Z. So the point would be 0, comma, Z. Okay, moving on to the next one. Now we've got two functions on the same graph. What looks like a quadratic function, the f of x function. F of x appears to be quadratic. And the g of x function appears to be linear. And we've got on the f of x function, it looks like we've got 1, 2, 3, 4, 5 labeled points. On the g of x function, it looks like we've got 3 labeled points. Now we're just going to start asking a lot of questions regarding this graph that has two functions on it. List all the labeled points that are solutions to y equals f of x. Again, it's just all the f of x points, all the labeled points that are on f of x. So we're looking at D and B and F and H and E. Similar question, only this time list all the labeled points that are solutions to y equals g of x. So all the labeled points that are on g of x. B, C, and E. List all the labeled points where f of x equals g of x. That's just their shared points. What points do the two functions have in common? And that would be their intersections, B and E. Next one, list all the labeled points that are solutions to f of x equals 0. So, solutions again, the key, where is y equal to 0 on the f of x function? So, all we got to do is concentrate on the f of x function. And of all those labeled points on the f of x function, which ones have y values of 0? And it turns out to be D and E. Otherwise known as the x-intercepts. Next one. List all the labeled points where g of x equals 0. So on the g of x function, the 3 labeled points on the g of x function, do any of them have y values equal to 0? And the answer is yes, E. On the g of x function, list all the labeled points on g of x that are solutions to x equals 0. So this time we're looking for g of 0. So on the g of x function, are there any labeled points that have an x value of 0? And yes, point C. List all the labeled points which show solutions to f of x being greater than or equal to g of x. So here's where we've got some comparing going on. We know we've got the f of x function, which is a quadratic. We know we've got the g of x function, which is linear. What labeled points show f of x being greater or equal to g of x? Well, it's just all of these points starting here, starting at this intersection, B, A, H, and E, because it said greater than or equal to. So B, A, H, and E. F of x is less than or equal to g of x. All the labeled points where f of x is less than g of x, so underneath. And really there's only one, and that would be point D. Continuing with our analysis of 2 different functions, this time we aren't even shown a graph. Some teachers teach it where you actually can make a graph out of it, but you never really know what the functions are. You don't know if they're quadratic, linear, because you're only given little snapshots of a moment in time. For instance, this first set of information is saying on the g of x function, when x equals 0, y equals -3. And on the h of x function, when x equals 0, y equals -9. And then it tells us what happens on each function at x equals 1, x equals 2, x equals 3, x equals 4. But it doesn't tell us anything about in between. We don't even know if these functions are actually continuous. So I don't teach this concept with the help of a graph. Your teacher might, I don't. So on the number line below, shade the intervals between the integers where the solutions to g of x equals h of x must exist. Okay? So where do g of x and h of x, between what 2 values that we know, do the 2 functions have to be equal to each other? Well, in order to do this, we need to do a comparison. And in this case, it would be g of x versus h of x. And here's how to do it without actually doing any graphing at all. At x equals 0, g of x is above h of x because -3, y equals -3 is a higher value than y equals -9. So -3 is bigger than -9. So at x equals 0, g of x is higher than f of x. Now, look what happens at x equals 1. H of x suddenly is higher, because the value of y is 7 when x equals 1 versus the value of y of 4 when x equals 1. So at x equals 1, h of x is higher. At x equals 2, h of x is still higher. At x equals 3, h of x is still higher. But at x equals 4, g of x is on top of it again. So now we just have to figure, we kind of have to fill in the blanks. In order for the two functions to at some point in time be equal to each other, then that means they must cross. Because only at their intersecting points are they equal to each other. Well, at some point between x equals 0 and x equals 1, they had to have crossed each other in order for their relationships to change. At x equals 0, g of x was higher than h of x, but at x equals 1, h of x is higher than g of x. So they must have changed positions, and in order for them to change positions, they must have crossed, and that's actually what we're looking for. So we're going to show the solution like this. We don't know where it happened, but we do know that it happened somewhere between 0 and 1. Now, it didn't happen between 1 and 2 because h of x stayed on top. It didn't happen between 2 and 3, but it did happen between 3 and 4. They switched positions, and in order for them to switch positions, they had to have crossed. So, the key. For two functions to be equal to each other at some point in time, okay, they must intersect. They must cross. And that's what we were looking for in this first example. Where do they cross? The next question is asking a little bit of a different analysis. On the number line below, shade the intervals between the integers where the solution or solutions to h of x must equal 0. So this time we're not comparing g of x versus h of x. We are actually only investigating h of x. So we're just going to go one by one, what the chart tells us. At x equals 0, h of x equals negative 9. At x equals 1, h of x is 7. At 2, it's 11. At 3, it's 2. And at 4, the solution to h of x equals negative 1. So what are the intervals where my solution to h of x equals 0 must exist? Well, again, we don't see the graph, but we kind of have to fill in the blanks. If it was negative 9 at 0 and positive 7 at 1, then 0 is contained in those two values. So it must have happened somewhere between those two values. 7 to 11, 0 is not in that interval, so it didn't happen in here. 11 to 2, not in the interval, it didn't happen. 2 to negative 1, 0 is contained in that interval, so it happened somewhere, we don't know where, but it happened between those two values of x. So, in order for a function to equal 0, it must have 0 between the two values of y, or solutions. Another way of looking at it is it just has to change signs. If something goes from negative to positive or positive to negative, it had to go through 0 in order for it to do that. Negative to positive had to include 0. Positive to negative had to include 0. On the number line below, shade the intervals between the integers where the solutions to g of x equals 2 must exist. Well, we're going to do it the exact same way we did this one, only this time it's g of x we care about. At 0, the value of g of x is negative 3. At 1, the chart tells us the value of g of x is 4. At 2, it's 6. At 3, it's negative 1. And at 4, it's positive 3. So, where did 2 have to happen? 2 is between negative 3 and positive 4, so it had to happen somewhere between those two values of x. Not really quite sure where. 4 to 6, 2 is not contained in 4 to 6, so it didn't happen here. 2 is between 6 and negative 3, so it did happen somewhere between those two values. And then we're back to negative 1 to 3. And yes, the value of 2 is contained between these two. So, again, it had to happen somewhere between those two integer values of x. So the key for this, look for intervals of g of x which contain the number 2. Now the last one. On the number line below, shade the intervals between the integers where the solutions to h of x equals 15. So we're back to h of x again. At 0, the chart tells us negative 9. At 1, it's 7. At 2, it's 11. At 3, it's 2. And at 4, it's negative 1. Look for intervals which contain the value of 15. No, 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 no. So, no solution. I'm not going to shade any intervals. So, the key would be look for intervals which contain 15. And having found none, the answer is no solution. Another part of your worksheet simply asks you different questions about a graph. I'm using the exact same graph that's in your worksheet, but I'm asking different questions. We're going to say that this graph represents the f of x function. It looks like it's a piecewise function because part of it is a quadratic, then it seems to go to a linear, then it seems to go to a constant, and then it goes back to a quadratic again. So on this function, which is defined as f of x, f of 7 is less than 0. So on the function, at the value of x equals 7, which is right here, is the function less than 0? And yes, it is, because it's down here, the y value is negative. So that would be a true statement. F of 0 equals 2. At an x value of 0, is the answer 2? And it's not, because it's negative 2. So that would be a false statement. F of 2 equals 0. On the function, at an x value of 2, is the answer, or the solution, 0? Is y equals 0 at x equals 2? And sure enough, it looks like it right there. Now, f of 4.781 equals 2. You might be thinking, how am I supposed to get that precise on a graph like this? Well, actually, you don't have to, because remember the constant part of the graph? The graph is a constant at y equals 2 from values of 4 to 6. So 4.781, even if we had to take our best guess as to where 4.781 is, and we said, what's the value of y at that position? The answer really is 2, because it's a constant. So that's true. F of negative 2 is a relative maximum. So on the f function, when x equals negative 2, have we found a relative maximum? And sure enough, we have. Because it comes up, it reaches its peak, and it turns around and goes back down. Now, the next question. I'm losing the graph on the picture, but we'll come back to it. F of 6 is a relative max. So, on the f function, when we have a value of x equals 6, is that a relative maximum? And the answer is no, because it comes straight across and then goes back down. Remember, for a maximum, it needs to come up and then immediately turn and go back down. So that's false. F of x equals 0 between negative 4 and negative 3. So, on the f of x function, when x is negative 4 and x is negative 3, between those two values, x is negative 4 and x is negative 3, is the function equal to 0? Is the y value 0? And sure enough, it is, right there. Now the last question, f of x equals 0 in 4 more locations. Identify these locations. Well, we've already located f of 2 equals 0 right here. So that's what the question is saying, in 4 more locations. So what are the other 4 locations where the solution to this f of x function is 0? Well, it looks like it's right here. I don't know what that number is, but I know it's between negative 4 and negative 3. Well, we got that one right there. So let's say that's the one they were talking about, since that was just what was asked. Where are the other ones? Between negative 1 and 0. That takes care of that one. It looks like right at f of 2. This one, between 6 and 7. And then it looks like this last one right here, between x equals 9 and 10. So that takes you through all the new stuff in Worksheet 7. Like I said before, the last page of Worksheet 7 is some review problems on solving.